Hey, good morning, class. We're going to be in our next lesson for the day. Today we are doing rational numbers. So go ahead and go open up your composition book, go to page table of contents, and we're going to be doing page 3 of notes today. So put 3 for the page, and we're going to be doing types of numbers. Okay, we're going to classify and talk about all the types of numbers that we have in our number system. Okay, so once you do that, go ahead and go to page 3 right here. So we're going to be on page 3. Remember, top right corner is your page number. And the topic, we're going to go ahead and put it on the very tippity top there. Let me zoom in a little bit. I think it's only zoom in. Okay. So on the top of here, we're going to put types of numbers. That is our objective for today. So that is the title we will be using. Okay. Types of numbers. Now, I'm sure you remember the types of numbers. We're just going to go over the ones that we need to talk about. Okay, the ones that we do need to classify. Okay, so the first one, the very inclusive one, the one that is the smallest in the Venn diagram, is going to be our natural numbers. Okay, do you remember your natural numbers? They were the first numbers that you ever learned. Okay, y'all might have called them in kindergarten or pre-K counting numbers. Okay, so the natural numbers are the counting numbers, and we call them the counting numbers because, well, how do you count people? How do you count objects? You start with the number 1 and you go up from there. So 1, 2, 3, 4. You don't start with 0. 0 is not a counting number. You start with a 1. Okay. Now, when you count, you do not put fractions or decimals when you count people. So it's one whole. So it's all your whole positive numbers. Okay. So those are your natural numbers. So there's no fractions here. There's no decimals. There's no number 0. There is no negatives here as well. So some of the examples of natural numbers are just your counting numbers. So the way you would count. So 1, 2, 3, and it keeps on going from there. Okay? But remember, no fractions, no decimals, no negatives, and no zeros. So they are the smallest of the types of numbers. They're very particular of who gets to be in their little group. Okay? Now, the next one after the natural numbers would be your whole numbers. Okay? So after our natural numbers, we have our whole numbers. Now, whole numbers are your natural numbers, okay? So they're all your counting numbers, but somebody else got invited, okay? And that is the 0, okay? The 0 has now been invited and been added into this group, okay? So whole numbers are classified, or the definition is the set of all positive counting numbers. Okay, so it's all your positive counting numbers and 0. Okay, so that 0 is now included. Okay, so you have to remember the 0 is neither positive nor negative. It has no charge. It's neutral. Okay, it's neutral. So some examples that we have of whole numbers are going to be pretty much all your counting numbers, except now we get to add in the 0. Okay, so I can do 0, 1, 4, 10, whatever you want to put in there. Okay, but as long as there are no fractions and there are no decimals and no negatives, we're pretty much good. Okay, so whole numbers are, again, all the natural numbers and 0. Okay, all the natural numbers and 0. Good. The next one is the one, I think you could have gotten this one in your 5th grade year, possibly. and that is our integers. Integers are the next ones, okay? These are the ones that make you work a little bit harder when it comes down to adding, subtracting, multiplying, dividing, okay? But integers are going to be all the natural numbers, so all your counting numbers, the zero, because that's a whole number, and now we're adding the opposites, which are your negatives, okay? So integers is the set of whole numbers, because remember, whole numbers are all the natural numbers, and their opposites. And opposites in this case are going to be their negatives. Okay, so integers, again, the set of whole numbers and their opposites. Okay, so it's all the natural and whole numbers here. So all the counting plus zero, and now their opposites, the negative. Now, zero does not have an opposite, so zero is just zero. But I'm talking about all your counting numbers here, okay? All of their opposites. So some of the examples here for an integer, we'll still have the zero as an integer. That is also, a zero is classified also as an integer as well as a whole number. The number 1, it's classified as a natural, a whole, and an integer, okay? So all of these are all classified as integers as well, the natural and the whole number. But when we get to their opposites, so I'm going to put a couple of more whole numbers there and natural, so 0, 1, 4. The opposite of a 1 would be a negative 1. The opposite of a positive 4, a negative 4, okay? And then it has all the other negatives and positives you can think of. So integers are all your whole numbers, all the natural numbers, and their opposites. Okay, so now we've got the negatives in here. What numbers do I not see here? I don't see fractions. I do not see decimals. You will not see them in those 3 circles, okay, those 3 classifications. No fractions and no decimals, okay? The next one we're going to talk about is, I call them the Hufflepuff of the group, okay, because they let everybody, just about everybody in, and that is our rational numbers. Okay, they let everybody in. So the actual definition of it, but there's a couple of numbers that aren't allowed in the rational numbers, but for the most part, majority are. So rational number are pretty much any number that can be written as a fraction. Okay, fraction or mixed number. Terminating decimal. Or, and terminating means it stops. So a terminating decimal would be 0.5 or 0.25. Okay, things that actually stop when you're dividing. Or a repeating decimal. Repeating decimal means just that, it goes on forever, but there's a pattern to it. The most popular repeating decimal, 0.33333, it goes on forever. No matter how much you divide, it's going to be it's going to be 3. Okay, so those are your rational numbers. Some examples. Now you remember, rational numbers can be any number written as a fraction. So let's go to natural numbers. How would I write this number 2? Can I write the number 2 as a fraction? Think back. You can. There's a specific number you can stick underneath the 2 to make it a fraction, the number 1. So if I put 2 over 1, I've just changed this natural number to a fraction. Therefore, all natural numbers are rational numbers as well. Okay? Whole numbers, the same thing. Remember, it's all the natural numbers here. So let's say we take the whole number 4. Can I change the whole number 4, into a fraction? Yes, you can, because you can stick a 1 underneath that 4, and you've just written it as a fraction. So all whole numbers are rational numbers, okay? Let's talk about the integers. Integers are all the whole numbers and natural numbers, but now let's talk about the opposites. Can I write a negative 10 as a fraction? Same process before. except now you have a negative. So negative 10 over 1. You can write that as a fraction. Therefore, all the integers are also rational numbers. Okay? Let's talk about our basic fraction. Our basic fraction is anything like 1/2. Okay, that's a popular fraction. That's a rational number. Your mixed numbers, 2 1/3. That is also a rational number because it could be written as a fraction. I could turn it into an improper fraction if I need to. Terminating decimal, that could be something like 0 and 25 hundredths, because when I divide my fraction out, it stops. So that would be a terminating decimal. And like I said before, the most popular repeating decimal is the 0.33, and it keeps going. So we put that bar on top to show you that it is repeating that number over and over and over again, okay? So those are some examples of rational numbers. Anything you can write as a fraction or a decimal, okay, a repeating decimal or a terminating decimal, that is considered rational numbers, okay? Now the last one, there's another one we're going to talk about, okay? And that is called irrational. Irrational numbers. Okay, so we talked about rational numbers. Now I'm talking about irrational. So if rational numbers mean that I can write any number as a fraction, what do you think irrational numbers would be? You cannot write them as a fraction. Very good. Okay, so irrational numbers, a number that cannot, be written as a fraction, okay? Or they get a decimal that goes on forever, but there's no pattern to it, okay? A decimal with no pattern, okay? So there's only a couple of examples for this one. I don't know if you learned this number in 6th grade or not, but it deals with circles, and it is the number for pi. Okay, you can Google what pi is. If you Google what pi is a number that goes on forever. Okay, but unlike the 0.333333, pi doesn't have a pattern. It's just a series of random numbers. So I'm going to give you some of the numbers for pi. It's 3.14159, and it'll go on forever, but there's no pattern. Okay, no pattern at all. So that is called irrational, because I can't write this as a regular simple fraction. I cannot, I don't have a terminating decimal. This decimal will never end. And it's not a repeating decimal because there is no set pattern to these numbers that keep on going on forever. So we call this number an irrational. It does not fit into any of these categories. So it's called irrational, okay? And those are the types of numbers that we're going to go over and we're going to be dealing with this year. Okay. Now, one way you might have seen these is in a Venn diagram. It's the best way to kind of see who belongs with who, when you can use the word all versus some. Okay, and I'm going to go over that right now and show you the Venn diagram. Okay. And remember, if I ever go too fast or if you need to catch up on copying, just pause it and go back and copy it, okay? Because we will be checking these books when we do get back together. So you want to make sure that you have everything copied down, okay? So we're going to start off with the smallest of the groups, okay? The one that is very particular and who gets to go into their little party, and that is our natural numbers, okay? They only allow your counting numbers. So there are very few compared to, when you get to the rational numbers who invite everybody over. So we're going to start off with a very small circle. Give yourself, split this paper at the bottom in half because we're going to do a couple of examples here. So we're going to make a small Venn diagram. So I'm going to do a small circle here. And this is our natural. Okay, the natural number is the smallest circle because they are very particular in who they let in. They only let your counting numbers in. So throw some examples in there. Okay, some examples would be like 5, 20, the number 3. Okay, but who is not invited? The 0 is not invited. Your decimals are not invited. The negatives and the fractions, all of them are not invited. So that's why the circle is so small. okay? Because it's only you're counting positive whole numbers, okay? That's it, okay? Now, the next party we're going to go to is our whole numbers. Now, I'm going to add a circle around this one. Now, the reason I added it around is because it's saying, hey, natural numbers, you are invited to my party. So I'm going to engulf you into my party. So your circle's in my circle. But he's going to add somebody else, isn't he? He's saying, all of y'all can come, all you counting numbers can come, but I'm adding the number 0. He's invited. I'm letting him come along, okay? So this tells me that all natural numbers are whole numbers. All natural numbers are whole numbers. So you see, as I go small to big, I can say the word all. If I go backwards, I cannot say the word all. I cannot say all whole numbers are natural numbers, okay? Because I cannot include the 0 into that small thing, okay? So whole numbers, all natural numbers, and 0 is added. Let's go to the next big party, okay? Now this integer guy, he's like, you know what, natural numbers? I know you're picky, but you're invited to my party. 0, you're cool. You can come to my party also. But I'm adding more people. I'm adding your opposites, okay? There's the integers. I am adding your negatives, okay? So again, the circle encompasses the other two because it's like all natural numbers are coming to my party. That 0, the whole numbers are coming to my party. And now I'm adding your opposite. So I'm adding the -4. I'm adding the -3. I'm adding the -20. All your opposites are now invited. Who is still not invited to the parties yet? The fractions, the decimals, the repeating decimals, the mixed numbers. They're all not invited yet, okay? They are not invited yet. So, again, all natural numbers are whole numbers. All natural numbers are integers. So you see, as I go from small to big, I can use the word all. If I go backwards, if I go from big to small, I use the word some. Some integers are whole numbers. Some integers are natural numbers. I cannot use the word all, okay? It's like I'm taking something big and shoving it into something really small. It doesn't work, okay? Now, the last group, remember my Hufflepuff group? They are the rational numbers. So this is going to be the biggest circle of them all because he lets everybody in just about, okay? Everybody but pi, okay? So pi's not invited. Cake is invited, but pie's not. I know, it's a corny joke. All right. So rational numbers says all the natural numbers are there. All the whole numbers are there. All of the integers are there. But now guess who gets to finally come to a party? Your fractions. Yes, your fractions. So let's throw some fractions in here. 1/2. Let's do a negative fraction. Negative 2 1/2. A repeating decimal, 0.33 repeated over and over again. A negative decimal, a -2.5. And you can keep on adding more and more and more and more. There's a lot of them, okay? So everybody except pi or any irrational number is invited there, okay? And so again, starting from the inside, the smallest circle, all natural numbers are whole numbers. All natural numbers are integers. All natural numbers are rational numbers, okay? So if I ask you classify the number 5, you're going to say it's natural, it's whole, it's an integer, and a rational number, and you are correct. Now, if they ask you what is the best name, the best quality, if they use that word best, and they've done it a couple of times, not too many, but if I ask you what is the best classification for the number 5, you want to go to the smallest circle, which would be natural. Natural is the best name, okay? So let's do some examples, okay? And then you're going to do a couple on your own, all right? So we're going to classify. Let's classify the number. Ooh, I'm going to give you a tricky one here. I've seen this happen a couple of times on the star. And when I get the results back, I'm like, oh, they missed that one. And it's just the star being mean to you, okay? So I want to classify 4 halves. Now, guess what letter A is always going to be? Letter A is going to be rational because you're going to see a fraction. You're going to go Rational. It's a fraction, ma'am. You just said no fractions are involved in here. But what's up with this fraction? It's an improper fraction, okay? And how do we change it from improper to proper? You must divide, simplify it out, okay? And so on this one, improper means your numerator is bigger than your denominator. Can I divide 4 by 2? Yes, I can. If I divide 4 divided by 2, that gives me a whole number, 2. So actually 4 halves is 2, okay? And how do I classify the number 2 now? Is it a natural number? Yes. Is it then a whole number? Yes. Is it also an integer? Yes, because you remember integers are all the whole numbers, which this is, and the opposite. So this is an integer. And is it a rational number? Yes, because I can write 2 as a fraction. It's right there, okay? So it also is a rational number. So try not to get tricked on that one. Take your time, do your thinking process, and think it through, okay? All right. Let's see. How about -2 and 3/10 repeated? How would you classify that? You would classify it as a rational number. Yes, it's a negative, but remember, I have a decimal here and no decimals are allowed in the integer world, okay? So it's going to be considered a rational number only. So rational. Very good. Okay. Now I want you to tell me if this statement is true or is it false? Can I say all integers are natural? Can I say all the integers are natural numbers as well? This is true. No, this is false. I cannot say all integers are natural. I'm going in. So when you go in, what can I change here to make it a true statement? What did I say when you go from big to small? We can use the word sum, okay? So if I want to make this a true statement, I can change this. I'll do number 4. I can change all to some integers are natural. That would turn that into a true statement. Okay, it's sometimes true. Some integers are natural numbers, okay? So when I go from small to big, that's when you use the word all, okay? So going into the circle, use the word some. Going out, use the word all in those statements, okay? All right. Okay, we're going to go ahead and get into the try it out part. So if you remember, on the back part, over here on the back, you're going to type up here, try it out, and you are going to classify the following numbers I give you, okay? You to classify the following numbers I give you. Make sure to press pause and then come back, okay? Press pause and then come back. All right, so let me go ahead and get you those numbers we're going to do right there. So I want you to classify the number 4, the number 1/8, the -3, and the -2.5. Press pause, answer it, and come back, and we'll see if you got it right, okay? Hey guys, hopefully you're back now. And let's see if you got them right. So the first one I gave you was the number 4. Okay, and I wanted you to classify that into as many categories you found. Okay, so if you notice 4 is a counting number, so that is a natural number. So you should have got natural, but that's not the only one. Because it's natural, it's also a whole number, okay? And remember, we're going from the small, we're working our way out. So it's also an integer, okay? And can I write 4 as a fraction? Yes, I can. So it's also a rational number, okay? So for number 1, you should have gotten pretty much all of them, okay? It is a natural, a whole, an integer, and a rational number, okay? Let's go to number 2. 1/8. Is 1/8 natural? It's not a counting number. Is it a whole number? Nope. Negative? Is it an integer? Nope. It's a fraction. So because it's a fraction, the only thing it can be classified is a rational number. Okay? So 1/8 is only a rational number. Let's go to number 3, a -3. As soon as you saw that negative, you should have thought integer. And then I don't see a fraction, I don't see a decimal, it's just a negative. So this is going to be an integer. And because it's an integer, it can also be classified as rational. Okay, so on this one, you should have got integer, but don't forget it's also a rational number. Okay, so if you're at the integer circle, go out, and it's also that as well. Okay, now let's do the last one. Last one is -2.5. It's another negative like number 3, but if you take a look, it has a decimal. Okay, so it can be classified as an integer. This one is only classified as a rational number. Okay, so if you didn't get them right, go over the notes again to try to figure out, okay, what did I do wrong? Just remember, once you classify the original number, go on the outside, go to the bigger circles, and it's going to show you what it all is. Okay, so 4 was a natural. Because it's natural, it's now a whole number, it's now an integer, it's now a rational number. Okay, fraction, it's a rational, can't be anything, I can go inside, it's on the outside. -3, if you look at your circle, there's the naturals, there's the whole, there's the integer, there's the rational number. If you look at the integer is right here. So it's an integer, it's a rational number, so it's going out the circle. That's what I mean, okay? So it's both of those, okay? And then number 4 is just rational, right? So thank you for watching. Make sure you have all your notes copied correctly. Go ahead and do the assignment for today, which is on rational numbers. Submit it, okay? If you ever get below a 70 and you want to redo the assignment, shoot me a quick email. You have to email me so I know you want to redo it. So send me an email to amunoz8@eaglepassisd.net, or send me a private comment on your assignment section and let me know, Ms. Munoz, may I please retake the assignment? I will send it back to you, but you have to let me know, okay? All right, guys, have a great day, and I will see you tomorrow, okay?